Hello everyone. Today we are back again to continue our learning of C programming language with memory and pointers. So last time we discussed, let's see what we discussed last time. Yes, so here it is. Let me open Vim. Yes. So last time we understood what are pointers, what is pass by value and pass by reference, when to use pass by value and when to use pass by reference. What is the meaning of this star? What is the meaning of ampersand? So ampersand is basically used to reference to some memory, and star is used to dereference in memory. What is the value stored at that specific address? If we want to get the value at some specific address, we use this star. And if we want to get the address where that specific variable is stored, then we use ampersand. Also, this star is used to refer the type of the what do we say, the type of the memory, the type of the variable that is specifically stored at that place in memory. So if we want to store, for example, float variable in some memory, so we float variable at some memory abc. So this variable now will can only store a float variable, for example 3.2f. Now abc can only store address of something which is a pointer, which is a float of which is of type float, but it cannot store. So this will work fine. But what if we try to define an int variable, int x equal to 3? ABC cannot store that. It throws an error. You can see there is a compile time error. Assignment to float pointer from incompatible pointer type int pointer. So this is not possible. So the type is already defined here. We discussed that, and we can see that how can we dereference the value using star, and how can we store the value there, and what is pass by value. When we pass by value, the value of that specific variable does not get updated. Yeah, a copy is getting created, and the any updates you are trying to perform inside a function is happening inside that copy variable. And if we want to update that specific position, we pass the address. Here we pass the address of those variables, and here we store it in two variables, and then we dereference those variables and try to store those in memory. Okay, so now now let's go back to the book and try to understand what we have to do further. Okay. So now they are asking, how do you pass a string to a function? Earlier, what we saw, we passed a, we simply passed a integer to a function. Now they are talking about how we pass a string to a function. You know how to pass a simple values and arguments to function. But what if you want to send something more complex to a function like a string? If we remember from the last chapter, strings in C are actually arrays of characters. So we have already discussed that strings are like array of characters. That means if you want to pass a string to a function, you can do it like this: void fortune cookie char array of message, and we are going to pass it. The message argument is defined like an array, but because you won't know how long the string will be, the message argument that does not include a length. That seems straightforward, but there's something a little strange going on. Honey, who shrank the string? Okay, C has an operator called size of that can tell you how many bytes of space something takes in memory. You can either call it with a data type or with a piece of data. For example, size of int. Or most machines, it will return the value 4. Size of turtle, this will return 9. Okay, so let's try to store it. HTML. size of int. Okay, so what we did here is we created a variable size of int, and we tried to store a value of we tried to store inside it the size of integer. Okay, so what did we miss? Hash include stdio.h. Now it seems fine. Now we are going to print that. Print, sorry, f percent d backslash, sorry, backslash, sorry, backslash n comma size of okay. Now let's try to build it. GCC name of file dash o output with binary name of binary which you want to execute, then execute it 4. So as it mentioned that the size of it on most machines it will return the value of 4. Let's also check the size of the specific string. Okay, printf, or what we can do is int size of tur equal to size of created PLES. So it's saying that there is a sentinel character also inside it, and it will also print that one too. So if we are going to use it as size, sorry, my mistake. So size, size of PUR is fine. Now let's build it again and execute it. So it is this printing 9. So however 1, 2, 3, 4, 5, 6, 7, 8, only 8 characters are present. However, it prints 9 because there is a sentinel character. As it is mentioned in the book, there is a sentinel character, end character, backslash 0. But a strange thing happens when you look at the length of the string you have passed in the function. So what we can do is we have some string, we will pass it to a function, and message occupied %i bytes backslash and size of message. Cookies make you fat, message occupies 8 bytes. Let's try it. Let's try it out. Don't waste time. Okay, first let me go in and close this. Then what we can do is we can create a void print, and inside this print str, and inside it we are taking a character and message, array of characters basically, and it is returning nothing, sorry, and we are printing oh, we will print the message is %s comma msg printf printf and size is %d and size should be size of msg. Okay. What do you think? Will it work or not? What is it saying? Percentage. So do we use the correct message, size of message? %i, it used %i bytes. So I think for size, okay. So %d is not the correct formatter. The correct formatter is %i. Okay. Format %i expected, but to I think we have written the correct code still. Let's check it out. there is some incorrect. Okay, it is not compiling. So we can browse over the internet and validate it. Size of character array in C. So let's see how they are presenting the solution. Percent %LD byte size of char type, but this is an array. Size D, SD size of ARR by size of ARR 0. So size LD. What is the compiler error? Format I expect two arguments, but argument 2 has type long unsigned int. Okay, so LD is LD of character pointer. Let's compile it again. Character pointer. And compiling. And on some machines this might even say 4 instead of the 4 byte. What happened? Why does it think the string we passed isn't shorter? It is trying to, my compiler is trying to, this is not the right way. So let's do one thing. Let's size t size equal to size of the machine. Sorry, my battery is low. Let me plug in the charger. Yes. The size of image. We try to comment a new size. So now print f size is %LD calculation comma size. Now this size filter size of character pointer. The size of character pointer. Open the Chrome. Browse 0. Okay. ARR is an Okay, let's leave it. Let's continue. What does it say? Maybe later we will have a look at it and try to discuss. Okay, so it is saying that if we have executed it, it would have printed 8. Okay. So when you create an array, the array variable can be used as a pointer to the start of the array in memory. When C sees a line of code in a function like this, so the computer will set aside space on the stack for each of the character in the string, plus \0 and character. But it will also associate the address of the first character with the quote variable. Every time the quote variable is used in the code, the computer will substitute it with the address of the first character in the string. In fact, the array variable is just like a pointer. So we are trying to understand that array variable is just like a pointer that will point to the starting address of the whole string. Quote. You can use quote as pointer variable and thought and though it even though it's an array. Where is quote? The quote string is stored at okay %p. The quote string is stored at okay. So what it is trying to say is our this code of ours didn't work, but if we are trying to understand, we have a message which we want to pass to it, and let's say message is hello, I am here. Now we will pass this message to print str message g. Okay, so it is saying that oh sorry. Now we execute this. So message is hello, I am here. So it prints out the message. But what if we want to print the address of this message? Print the message is stored. That means the starting point. Stored at %p \n, comma message. The message is stored at this address. This means that not message is stored at this address means the starting. This m is stored at this address. So let's assume, we can try one thing. Let's take a pointer to a character. Okay, character pointer. Let's assume it is first. Okay, so it will store the message where this message address is stored. First message, and what we can do is, let's assume another second, and at second what we can do is, let's try to assume message +1. We are incrementing the message by 1. So if we try to print it out, I'm just guessing, I'm not sure what will happen in this case. The value at first is, we can do %s, and then we can do, so it is a pointer. We can give it a first, print the whatever the string it is there, print okay. So if I, oh sorry, I forgot to backslash n, only then we will be able to see it. Now let me clear it again and build it. Now let's see. So the first message is hello, I am here. The message is stored at this specific address. Now what I did was I took the first address out of the first variable, first character, not first variable, first character. For example, the message was hello, I am here, and it is stored in a message. And we can refer to the first address of h variable. H is stored at, let's assume, this address, and this will be confusing. H is stored at this address. Now we can refer this address by using MSG. So what I did was I told it that I'm going to store this at first. So now first is pointing to this specific address, and when we try to print out that value, it prints the whole string. The value of at first is hello, I am here. Okay, it prints the whole string. Then I took the second, and I incremented the address by 1. So incrementing the address by 1 means now I am pointing to E. Now I'm not pointing to H. So and then I try to print the whole string. So it starts from ELLO, I am here, and it prints that ELLO, I am here. So this is the behavior of pointers in string. You can increment the pointers of this is the first address. Okay, now if you want to shift to the second address, you can shift it to the second one by incrementing it by 1. If you want to shift to the third, you can shift to the third. But as we have used %s, so it will try to print the whole string until it faces a sentinel character or \o. But let's assume we want to print only the specific character at that. So what we can do is, let's do %c, I'm not sure, and what is the value at that specific string. Now let's try what will happen. As per my understanding, now the first line, the value at first should be H, the value at second is E. The value at first is H, the value at second is E. So we can do the character value in order for us to remember, and then print F from first to end is like a %s / comma the first address string from end is to second. Hello, I am here. ELLO, I am here. So in order to understand that, or in order for string to print, we just print the address of the first variable, address of the first character. We don't print the value of the first character, we print the address of the first character. And in order to print the character, we can print the value of the first character with %c, which is a format. What do we call it? Format. I specify something. And you can also increment the address by increasing them 1 by 1. So what we can do, we can also try here to print the whole string. So int len of string equal to by 1 by 1. Int len of string equal to size of I don't understand why this is not working. Size of MHG. So this didn't work now. Print printer sizes %ld backslash len of so no, this time not sure about it. How we can get the size? I don't think it will work. So type int size of message, size of array parameter message will return, size of character pointer. But we are using it int. Size of character pointer. Not sure how to get the size. So we understand that that we are passing a pointer. It is a message is actually a pointer variable. So it is not actually a variable. It is a pointer variable. Message is actually a pointer variable. It points to the message. It's just the size of message is just the size of pointer, and that was size of operator returning a weird result. So what we can do here is to print. We want to print uh, file current val not equal to EUF. I'm not sure how. Oh, I am guessing this. Yeah, current val. Will this work? Let's try it out. So now we have the message. So let's try to print. So current val equal to value at message. Printf percent. You want to be character dot current val. Current val. Okay. So what we can do here is printf current val. Now what it is showing us before token, also semicolon. Now what we have to do is message equal to message plus one. We are implementing the starting pointer. Now let's try to build it, execute it. Oh, segmentation fault because it doesn't. The program didn't exist. The end condition was not correct. So let's assume. Let's do one thing. Int count equal to 0 and count is less than 10 and count equal to count plus 1 minus 6. I'll try to put it. Okay, so it is it is printing till m. Now let's try to understand what it prints. Here, after here there is empty. More information from the memory. So we have to stop here. Is it backslash? And val equal to is not equal to backslash. So this is the endpoint where the program will stop. If current val is not equal to, because we know what is the end of a specific string. It is what is the end of a specific string? It is always the sentinel character. So what we did is we started from the message, take the value what is present at that specific pointer and print it. Then we increment the address by 1. By 1 means it is not like incrementing by 1 plus 1 2. It increments where to the total, for example, specific address. For example, if we assume that character is of some specific size, 4 byte, 2 byte, 3 byte, whatever it is. So it will jump to the next address where the next variable is getting stored, and it starts to print that. We can also print the address if you want to see. Print %p backslash n, comma. We are printing the address now. Oh, what happened? Change. Okay, maybe I'm not sure about it. Why it is not working now? Something wrong. So we take the current value, which is empty. What we can do is, yes. This was a mistake. Equal to value at message. Yes, now it is fine. And after incrementing, what we can do, current val equal to pointer to message, or we can do it again. Then now it is fine. Yes. Earlier, I think it automatically picks the sentinel character when I am not defining the value inside it. That's why do while loop is used, I think. Now this is the most important scenario for do while loop. So first execute the code, then execute the loop. So this will work fine. And we were trying to print the address also. Let's try again. Percent p backslash n, comma, and then we are trying to print the address of the messages wrote. So I just stored at 5E8, then 5E9A, hexadecimal B, C, D, E, F, then F0, F1, F2, F3. So it is, and hexadecimal is of like 0000, 0010, 0011. So it is of basically hexadecimal. Let's check it out on the internet also. Decimal is a number with base 16 can be the number. ABCD, yes, it is hexadecimal. 1010 is A, 1011 is B, 011 is C. So you can represent 2 raised to 4, that is 16. So till 0 to 9, then ABCDEF. What is hexadecimal size in C? So let's move forward now. The computer sees the function as like this, and it sees the function like that. This character value in increment and address. Okay. What is size of function is an operator? Nope. An array variable can be used as a pointer. The array variable points to the first element of the array. We remember that. If you declare an array argument to a function, it will be treated as a pointer. So this is I think this is the most important one. If we declare an array argument to a function, it will be treated as a pointer. So if we are defining it as this, it will be treated as a pointer rather than a complete string. What is the difference? Address of a pointer operator, yes. And operator, we can even also find the address of a pointer variable. If I create a pointer and does the pointer variable live in memory? Yes, it also lives in memory. So this was, oh no, not this one. Can I convert a pointer to an ordinary number? Almost yes. The compilers typically make the long data type the same size as memory address. So if pointer is a pointer, you want to store it in long variable variable a, you can type a long p. We will look this later. Now they are trying to make us play some game. We have a classic trio of bachelors ready to play the mating game today. Tonight's lucky lady is going to pick one of these fine contestants. Who will she choose? Okay. Now we have to write the answer based on code. Int contestants 1, 2, 3. Pointer to choice. Well, choice is pointer to an int. Okay. Contestants. Exactly. Okay. So if we try to understand, so let's take it here. Let's note it down here. So contestant is an array. Contestant is an array which contains 1, 2, and 3. Now let's create a variable choice that is pointing to contestant. That is storing the address of first contestant. And now contestant 0 equal to 2. Contestant 0 equal to 2. So it means this has been changed to 2. Now the array becomes 2, 2, 3. Okay. Contestant 1 equal to contestant 2. Contestant 1 equal to contestant 2. 1 equal to contestant 2. Okay. This also gets updated. And contestant 2 equal to pointer to choice. Value of choice. Value of choice is so this is interesting. This is interesting. This is, so why? Because we have to understand this. What happens? Choice contains the contestant. Okay. So choice contains the address of 1. This is clear. Now contestant 0 equal to 2. But what it is saying is contestant 1 equal to contestant 2. So whatever the value is stored at 1 will be stored at value 2. And we are storing the 2 to be value of choice. So what happens is we are changing the value of 2. We don't know about this. To be the value of choice. And choice was address of 1. That means it is 1 here. And if this is 1, then this value contestant 1 must also be equal to contestant 2. So it is also 1. Then I am going to pick contestant 0, 0, 1, 2. So first. So it will pick the contestant 1. Let's check the answer. Oh, we are wrong. We are absolutely wrong. Here, twice contestant. Why is it 1? Contestant. Oh, okay. Sorry. Choice was the rest was the address of contestant 1. So address of contestant 1 has been changed. It has been updated to 2. And here it will be 2. There it will be 2. This was the correct answer. Yes. choice is now the address of contestants array. Okay, so pointer to choice. No, he has not explained it clearly, but I got the gist of it, that contestant 0 is storing value 2. So here choice is storing the address of contestant. Choice is now storing the choice pointed to a choice. Now value at choice equal to contestant, and contestant equal to whatever is the value at choice, and it is storing the address. So basically choice was storing address of contestant first variable. Whatever be the, it has the address. So contestant will be the value at choice. Value at choice will be equal to value of the first variable, and value of first variable equal to 2. So it is getting equal to 2. Now let's move on. But array variables aren't quite pointers. Even though you can use array variable as a pointer, there are still quite differences. Let's see what are those differences. Character s is equal to how big it is. Character pointer to t equal to s. Can we do it? Size of an array is the size of an array is the size of an array. You have seen that size of a pointer returns the value 4 or 8 because that is the size of the pointer on 32 and 64-bit system. Okay, size of pointer. But if you call size of an array variable, C is smart enough to understand that you want to know how big the array is in memory. This is S. How B internal size of S, size of D. Okay, so what we can do is we can try it here. So print f percent comma again. Now we can try. Now it prints 16. Now it exactly prints 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Yes, because here it was not printing the same value because here it was passing the pointer rather than the exact string. So that was the earlier confusion which I was facing. Okay, so here we can do it, but if we try to perform the same thing, here it will not work. It will fail. And it did not compile because here it is passing the pointer. It is MSC cannot be referred as an array, it can be referred as a pointer, but here it is referred as an exact string. The address of the array is the address of the array. A pointer variable is just a variable that stores the memory address. But what about an array variable? If you use AND operator on an array variable, the result equals the array variable itself. Okay, pointer equal to s, and t is not equal to t. If a coder writes address of s, that means what is the address of the s array? The address of the s array is just s. But if someone writes address of t, that means what is the address of the t variable? An array variable can point anywhere else. When you create a pointer variable, the machine will allocate 4 or 8 bytes of space to store it. But what if you create an array? The computer will allocate space to store the array, but it won't allocate any memory to store the array variable. This is one most important point. So it is trying to say whenever we try to create a pointer variable, the machine will allocate 4 or 8 bytes of space to store it. But whenever we create an array, the computer will allocate space to store the array, but it won't allocate any memory to store the array variable. Now let's try to read the case of the little list and try to understand what they have been saying. The mansion had all the things he had dreamed of: landscaped rooms, chandeliers, its own bathroom. The 94-year-old owner uh, had been found dead in the garden, apparently of a heart attack, natural cause. The doc thought it was an overdose of heart medication. Something stank here, and it wasn't just the dead guy in the gazebo. Walking past the corpse in the hall, he had approached Mumford's newly widowed 27-year-old wife, Bubbles. I don't understand. He was always so careful with his medication. Here is the list of doses. She showed him the code from the drug dispenser. It so the list of doses goes like this: 132,000. The police say I reprogrammed the dispenser, but I'm no good with technology. They say I will wrote this code. I wrote this code, but I don't think it will compile, will it? So she slipped her manicured fingers into her purse and handed him a copy of the program the police had found lying by the millionaire's bed. It certainly didn't like it would compile. Printf issue is percent %I, 3 doses. Okay. What did this expression 3 doses mean? 3 wasn't an array. Bubbles blew her nose. I could never write that. Anyway, a dose of 3 is not so bad, is it? A dose of size 3 wouldn't have killed the old guy. But maybe there was more to this code than met the eye. Interesting. Why array really starts at 0? Oh, the biggest question. An array variable can be used as a pointer to the first element in an array. That means you can read the first element of the operator either by using bracket notation or using the operator like this. So if you want to directly print the first value as we used here, if you want to print the value of the first, we can directly use message here. We can directly use message here. If we want to directly read the first value, we can do the message here, and it will still print the first value. Now it fixes the edge here, so it is clear. So if we want to get the first value, we can directly use the pointer. Because an address is just a number, that means you can do pointer arithmetic and actually add values to the pointer. Okay, to the next address. So you can use brackets to read the element with index 2, or you can just use to the address of the element. So it is correct. What we did was we uh, incremented the first message plus 1 and try to store the address specifically there, and third, and then we can also print what the char value at third is percent %c, comma. So we can take the message or after first, whatever it is, plus we can increment it by 2. Whatever the value is at that specific address, first plus 2, it will print that value. So yeah, the first is H, second is E, third is L. They are mentioning the same thing. We are clear of it, or they are mentioning we can use. I'm mentioning, or the other way we can use is both. MSG is also one way. Totally depend upon your understanding. HELL. Okay, so it is here. Are equivalent. That's why array begins with index 0. So that's why array begins with index 0, because if we want to print the first element, we can directly use star drinks or star MSG. So that's why we have to, for in order to go to the first element, we have to point +1. We have to increment that with 1. So +2 if you want to go to the third element, +3 if you go on to the fourth. Use the power of pointer arithmetic to mend a broken heart. Pointer to a message. What expression do you need to print for the 7th character? Very good. So what do you think? Put. So it is a message. 7. The function needs to print E. So what we will do here is MSG plus 1, 2, 3, 4, 5, 6, 7. So here we will use 7. MSG value at MSG plus 7. Puts. So okay. So puts, we don't have to use pointer. We just have to give the MSG plus B points to letter E. How come? MSG plus B. It's a 6. Sorry, it is 6. 1, 2, 3, 4, 5, 6. It's a print letter C. Or they are saying print letter E. A. So C. Okay. So for C, we can print with 6. 1, 2, 3, 4, 5, 6. And it will print the whole message. We can try this out. It's interesting. So white print content, and we are, rather than using, we are pointing MSG. So again, what we are doing puts, and we can use some sort of offset here, whatever offset they want us to print. What we will do, MSG plus offset. So here we will create a string here. My name is, whatever the name is. Okay. The name is Captain. So, and what we want to print here is print this name, and what will be the name? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it is at the 11th position. So what we will do is we will pass print content, the message, and the offset. Offset is 10. Oh, sorry. Name. Now let's build it and execute it. So the name is getting printed, Captain. I think 11, because place is also getting printed. It is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So if we do MSG, it will print this. Okay. MSG plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Okay. Offset. This is the power put. Input we can directly pass and print that value. So we don't have to do %d, %f, put will automatically understand. Let's move on. Why pointers have types? Exactly, pointer variable have different types of each type of data, have different types for each type of data. If pointers are just addresses, then why do pointers have types? Why can't you just put all pointers in some sort of general pointer variable? The reason is that pointer arithmetic is sneaky. If you add 1 to the char pointer, the pointer will point to every next memory address. That's just because the char occupies 1 byte of memory. So we have to understand this. What we did, we also saw this output in our program. So it is getting incremented by 1 byte is basically 8-bit, but a hexadecimal is only 4-bit. So it is getting incremented by 4-bit. If you can see, it is getting incremented by 4-bit because it was a character pointer. Sorry. Because it was a character pointer. What if you have an int pointer? Int usually take 4 bytes of space. So if you add 1 to an int pointer, the compile code will actually add 4 to the memory address. Okay, so what we can do here is we can reduce our string to only hello. And compile it and execute it. Okay, and we can print something here. Put character pointer memory iteration. Okay, this will bring us something. Character pointer memory iteration. What we can do here is something like this. Iterator not can iteration start, and here we can write iteration and now it is fine. Whatever. Okay, so it is incrementing by 4-bit. Now what we can do here is we can also create an integer pointer. Now what we are going to create an int. Let's just name it also message. We don't care about that, and we will iterate over it and try to print each of the variable. So similar to we will create the but for the integer array, how we will define the end. For integer, what we can do here is we can use a size of operator equal to size of message. It will print me the size of. So we can create a for loop int I equal to 0, I less than so size I plus plus. Then what we can do here is first we will print percent %d backslash n. So whatever we have the current value, and current value we can calculate with current val to whatever is the value is at that specific address. So address is our message, and then we will run val, and then we can also print the pointer address from whatever the message it has, and then we will increment by 1. Okay, and for rather than for using character, we will replace character by int. Here other part we will replace by end. And here what we will do, we will create an integer of characters, sorry, array of integers list equal to 1 2 3 4 and 5. Then we will print int this list. Okay, now let's execute this code. Now this our current val, and we have not mentioned what is our current val. Current val is integer size of integer pointer. Size of integer pointer. What is the size of integer pointer? Int. Let's try to let's see how can we calculate it. Data type, size of operator. Just need size of array name upon size of array name index. Okay. Can you determine the size? Size and have a length array and C. So they are saying data type. Array size of name of array upon size of name of array by index. One array element. Okay. Size of whole array upon acha. Okay. So they are saying that what we can do here is size of message 1. Still it is not working. Name of array. Okay. We are passing a pointer here. We are not passing the that's why it is incorrect. So what we can do here is length. What we can name it as name it as size. We can name it as size, and here we can calculate the size. Int size equal to size of list, size of or we don't have to use it. This will just work. Now it is fine. So 1, 2, 3, 4, but it doesn't get ended there. Keeps on executing because the mistake was and it was mentioned inside of list 1. Now it is fine. 1, 2, 3, 5. And if we see the jump here we can see that 88, 89. So one jump means hexadecimal by 1, 4-bit. Here we can see 4. So 1, 2, 3, and then 4. 1, 2, 3, 4 into 4, 16. So 16-bit. 16-bit is stored. One specific. And we can also, by the way, we can also put that value then here. Print f %d backslash n comma size of list 1. Long and silent. So here we can see the size is of captain and then size is of 4. 4 byte, 4 16 bits, 2 byte. Okay, so it is fine. Now let's move forward. We can num plus 1% p address jump. We were able to understand the address jump. So here it was DAC and then the jump on DB0, AC B0, D, D, E, F and 0, 4 bytes away from nums. The case of lethal list. So 3 doses equal to pointer to, or we can write it as in this manner also. That's why they were saying doses 3. Pointer to 3 plus doses, or pointer to doses plus 3 and doses 3. So we can use any of that. That's why. Don't go back before the start of the allocated memory space. So it is, they are saying that we can also decrease from the pointer, but we must not go beyond this beyond the point where we have started. So array variables can also be used as pointers. It is very important point and clear, but array variables are not quite the same. Size of is different for array and pointer variables. So for array, as we can see, we use size of for an array. But it returns the size of total array, size of the whole list. So size of the whole list. So if we see, it returns 1, 2, 3, 4, 5, 6, size of the whole list. And size of so we have to divide it by the single. So the size of single element is 4 bytes, and so the whole list must be whatever 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 into 4, 20, 12. We have to add 20 by 4, and the size of list will be 5, and we have a iterate over 8 over 5 and print out the elements. Well done. Okay, fine. Let's move on forward. Now the next thing we want to understand is using pointers for data entry. You already know how to use how to get the user to enter a string from a keyboard. We can use a scanf function. We already used this earlier. So in the first chapter, so character name 40, enter your name, then we went %30s, then here scanf will read to 39 characters plus the string terminator \0, and the name which we are passing here is the address. So it is the address of the, it is the address. So how can you scanf work? It accepts a char pointer, and in this case you are passing it an array variable. By now you might have an idea why it takes a pointer. It's because scanf function is going to update the contents of an array. Yes, that's why it takes a pointer, because it is going to update that. So if we take directly the value, so it will make a copy, but it does not want to copy something, it wants to update it. So entering numbers with scanf. Now what if you want to enter the number? So here we cannot use directly age, we have to use address of age. Enter first name and last name. So first Sanders, last clean field. Okay. First enter. So these are the format. Enter an integer, floating point numbers, 29 characters, tab to 29 characters, terminator \0, the floating point number. Now the more, be careful with scanf. There is a little bit problem with scanf function. So for all code you have written, has very carefully put a limit on the number of characters that scanf will read into. So we have mentioned %39 as name, %32 as card name. Why is that? After all, scanf use the same kind of format string as printf. So, but when we print a string printf, we just use %s. Well, if you use %s as scanf, there can be problem if someone gets a little type happy. So char food 5, %s food. Favorite food is liver, tangerine, toffee segmentation font. the program crashes. The reason is because scanf writes the data way beyond the end of the space allocated to food array. That is the problem. So we have only mentioned the size, we have only mentioned the space for food variable only 5. So it can only write liver. But what if someone tries to input something like this? From this, from this space, the code space is an illegal. That's why scanf can cause buffer overflows. If you forget to limit the length of the string with scanf, then any user can enter far more data than the program has to store. The extra data then gets written into memory that has not been properly allocated by the computer. Now you might get lucky and the data will be simply stored and not cause problem. But it's very likely that there is a chance that the buffer flow will happen. It might cause about trap and crash of the system. FKits is an alternative to scanf. So I think that was enough for today from my side. It's been an hour and 12 minutes, so I think I will get to this in the evening or tomorrow morning. Okay, thank you a lot.